Assalamu alaikum and welcome to the first exam solution. So we have here the first problem. Consider the control system shown in this figure. If the unit step response is critical damped with the steady state error is equal to 0.1, we need to find K1, K2 and the unit step response y of t. So to do so, the first thing we need to find the closed loop transfer function, which is the y over r. We need to find it. So if we examine the figure, we can see that this one is actually feedback. So it can be written as K1 over S plus 2 plus K1 K2, which is cascaded with 1 over S, so it can be written as K1 over S square plus 2 plus K1 K2 multiplied by S, which is a feedback with K1. So we can write the overall closed loop transfer function as K1 over S square plus 2 plus K1 K2 S plus K1 square. So now from the first information that the steady state error due to unit step is equal 0.1, we know that E steady state is equal to R steady state minus Y steady state, and R steady state is units, so 1 minus Y steady state, which will equal the error, which is 0.1. So this means that Y steady state is equal 0.9. Now we know that Y steady state is equal to DC gain, which is the value of the closed loop transfer function at S equal to 0. So this is the closed loop transfer function T of S. So when S equals 0, it will give us K1 over K1 squared, so 1 over K1. So simply K1 will equal to 1 over 0.9, or you can write it as 1.11. So now we have the K1. Next we need to find K2. The information given here is critical damped. Critical damped, this means that zeta is equal to 1. Now if we recall the second order characteristic equation, it's written as S squared plus 2 zeta omega n S plus omega n square equal to 0. Now this characteristic equation must equal to this characteristic equation. So simply from here we have that omega n is equal to K1, because omega n square is equal to K1 square. So now we have omega n, and from the critical damped we have zeta, so zeta is equal to 1. So now we can say that 2 zeta omega n must equal to this term here. So now we can write that 2 zeta omega n must equal to 2 plus K1 K2, but zeta equal to 1 and omega n is equal to K1, so 2 K1 is equal to 2 plus K1 K2. So from here we can find K2, which will equal 2 K1 minus 2 over K1. Now if we do the math, this will equal to 0.2. So now we have also K2. Now finally we need to find the unit step response y of t. So we know that for the second order system critically damped without zeros, y of t will equal y steady state 1 minus exponential minus omega n t multiplied by omega n t plus 1 all multiplied by u of t. So now if we substitute, we have omega n and we have y steady state, so this will equal to 0.9 multiplied by 1 minus exponential minus 1.11 t multiplied by 1.11 t plus 1 u of t. So this is the answer for the first question. So in the second problem, we have a single flow graph, and we need to write the state space representation, which means that we need to write the matrices A, B, C, and D, given the state variable x, which is the x1, here this is x1, and we have x2, this is x2, and we have x3, this is x3. So and also we have the input here and the output here. So first thing, if this is x1 and here we have integrator, so this will be the x1 dot. Again, this is the x2, this is here you have integrator, so this will be the x2 dot, and here x2 dot is equal to x3. Interesting. And here also we have integrator, this is x3, so this will be the x3 dot. So now let's write the first equation for the x1, which is the x1 dot equal. Now x1 dot equal to what? The first thing here we have x1, so this will be x1. Then here we have 2 multiplied by x2, so plus 2x2, and here we have 3 multiplied by x3, so this will be plus 3x3, and here we have the input multiplied by the 1, so plus u. So this is the first state equation. Now for the x2 dot is very straightforward because it's given here. So we have x2 dot is equal to x3. So what about x3 dot? Now this is x3 dot. Let's write it. x3 dot will equal. Now the first thing, we can see the input is entering with the scaling equal to 4. So this will be 4u. Then here we have a feedback from x2 with minus. So this will be minus x2. Then we have here x1 with gain minus 2. So this will be minus 2x1. And here we have x3 with minus 3. So this will be minus 3x3. Now in matrix form, if we write it, this will be the x dot will equal the state matrix A multiplied by the x plus the input matrix B multiplied by the u. So this will be should be 3 by 3, and this should be 3 by 1. So now let's write the x1 dot equal to x1, so this will be 1 here, 2 x2, so 2 here, and 3 x3, so 3 here. There's input, yes, there's input, so 1. What about x2 dot? X2 dot only equal to x3, so this will be 0, 0, 1, and here there's no input, so 0. What about x3 dot? Here we have minus 2x1 minus x2 minus 3 x3, and here we have a 4 for the input. So now this is the matrix A that we are looking for, and this is the matrix B that are we looking for. Now for the output equation y, now y equal to what? If you look here, y is equal to x3 dot plus x1, so this will be the x3 dot plus x1. We need to write the output in terms of the input and the state, so we will substitute x3 dot here, so this will equal to now here you have x1, here we have minus 2x1, so this will be minus x1 minus x2 minus 3x3 plus 4u. In matrix form, this will equal the output matrix C multiplied by the x plus the direct input matrix multiplied by the u. So this will equal to the coefficient of x1 is minus 1, x2 is minus 1, x3 is minus 3, and the u is 4. So now this is the matrix C that we are looking for, and this is the matrix D that we are looking for. So let's discuss the last question. Simply here we have a single flow graph, and we need to find the closed loop transfer function y over r using the Mason gain formula. Now if we examine the single flow graph and we are marking the nodes, let's assume this is node number 1, this is node number 2, this is node number 3, this is node number 4, 5, 6, and 7. So let's write specifying the loops. Examining node number 1, we can see that there's 2 branches out from it, so impossible to do looping here. So let's go to node number 2. In node number 2 we have this is the first loop that we can see, so this will be the L1, which will equal to G square H. There's no other loops, so let's put X here, and this loop is going through nodes 2, 3, 4, and 7. If we go to node number 3, we have also here another loop. If we write the loop gain L2, it will equal to minus G H, and it will pass through nodes 3, 4, and 7. If we examine again, we have also another loop here. If we write the loop gain L3, this will equal to minus G square H, and the shaded nodes are 3, 4, and 5. Now if we examine here, we can see that 3 is common and 4 is common, so this means that all the loops are touching. So all, here we can write all the loops are touching. So all the loops are touching. This means that the determinant according to the Mason-Gain formula is equal only 1 minus the summation of all loops. So 1 minus L1 plus L2 plus L3. Now notice here that L3 and L1 are equal magnitude, opposite in direction or negative in sign, which means that delta is equal only 1 plus GH. So now let's find the paths from R to Y. So simply this means that you are here and you are looking toward the Y and you are asking yourself how many ways I can go from R to the Y in the direction of the arrow without including any nodes more than once. Now the first one is the obvious, the shortcut here, or the direct path. And if we write here the path gain P1, it will equal to G cube, and this one will pass through all almost all the nodes from 1 to 6, 1 to 6. So this will touch all the loops, which means that the cofactor for it, delta 1, is equal to 1. Also we have another path here. So this will be the P2. The gain for that is G. It will only pass through node 1 and 6, so it will touch none of the loops, which means that delta 2 will equal to delta. So now we are on the stage to write the closed loop transfer function. Y over R according to the Mason-Gain formula is equal P1 delta 1 plus P2 delta 2 over delta, which will equal to G cube multiplied by the 1 plus G multiplied by the delta 1 plus the GH over the delta 1 plus GH, which can be written as G cube plus G square H plus G over 1 plus GH. That's it. Thank you for watching.